Good Monday morning to everyone. Today we're going to continue on with about acids and bases, and we're going to be talking about strength of acids and bases. Before we do that, first of all, it's been a while since we have, I guess, been together. Well, of course, it's been a while since we've been together, but it's been a while since we've done, something school related since we had last week, essentially off due to the bad weather. First and foremost, I hope that everyone is safe. I hope that everyone, was okay with the storms that we had. It's just, it's just that time of our lives right now, folks. And, hopefully we're all coming through this as well as we can. And now we can get back to learning some stuff because, believe it or not, having something to kind of preoccupy your time and preoccupy your thoughts and your mind with and learning something new, that's actually really beneficial. You may not think so, but it is actually really beneficial, especially during times of stress and just hard times. So I'm happy to be back with you, and I hope that you're well. And we're going to get through this. Once we've gotten through this little bit of notes, I'm going to paraphrase a lot of what's on here and simplify what's on these notes a lot. It's what I would typically be doing if we were in the classroom together. All right. So before we get started, what we went through the last time, 2 weeks ago, what we went through, which is all still posted to Classroom. So if you need a refresher, those notes, those different things are still on Classroom if you want to refresh your memory. But we've been talking about acids and bases, and just a couple of review things just to remind ourselves about what's an acid, what's a base, how do I know I'm dealing with an acid or a base. Biggest thing for right now is just to remember most acids have hydrogen. Okay, most acids in their formula have hydrogen at the beginning of their formula. All acids are going to have the element hydrogen in them. That's part of what makes them an acid. Bases tend to have hydroxide, polyatomic ion hydroxide in them, OH negative. They usually have it in their formula, but I believe the very last set of notes that we went through 2 weeks ago at the end of the week, 2 weeks ago, mentioned what happens to acids and bases in water. Okay. And when an acid dissolves in water, it forms that hydronium ion, H3O plus. An acid gives a hydrogen to a water molecule that makes H3O plus, hydronium, and a base in water produces hydroxide. Okay, so that's a very brief review of some very basic things about acids and bases before we get into strength. Now, we've probably used the term strong acid before. You have a strong acid in your stomach, hydrochloric acid. But a lot of times people think that word strong has to do with how harmful it is, how dangerous it is. It's a strong acid, then it's going to eat through my skin and it's going to eat holes through metal and this, that, and the other. And, that's not necessarily wrong, but that's not why acids or bases get considered to be strong or weak. And so that's what we're going to be looking at. Okay. All right. So first of all, what determines strength? It says strength depends on the polarity. Remember, has to do with oppositely charged ends. With molecules, atoms that are bonded together, sometimes one element has a stronger attraction or a stronger pull for the electrons that it's sharing with another element. And that creates a polar molecule. One end is a little bit more negative because it's attracting those negative electrons towards it. And one end's a little bit positive because it's not holding on to the electrons as strongly. Okay. So strength's going to depend on that polarity concept between the hydrogen and whatever other elements with it, and the ease with which the bond can be broken. Okay. So acid-base strength actually has a lot to do with how easy is it to break a bond between the hydrogen and what it's attached to. And it says strength increases with increasing polarity and decreasing bond energy. Bond energy is the energy that holds a bond together. So what this is saying is an acid or a base is considered stronger when it's easier to break apart. And that may seem kind of contradictory. You may hear that and think, that doesn't make sense. If it's strong, shouldn't it hold together better? But that's that's just kind of our brains on a big scale, thinking about what strength means to us. But that's not what it means in terms of what acids and bases do. So let's look at what's going on. All right, so strong acids. What's going to make an acid considered strong? All right. As I just mentioned a minute ago, when an acid is dissolved in water, they donate their hydrogen, their positive hydrogen, to a neutral water molecule. Remember, this is H2O, neutral. When you add a positive to a neutral, we make a positive hydronium. All right, this is what acids do. They make hydronium when they're in water. And this process is called ionization. And that's not that important. Just throwing that out there for you. So a strong acid ionizes completely in solution. Here's what that means. A strong acid it says completely, and the word completely to us means 100%, and it's not 100%. It's like 99.9%. But a strong acid is one that will 99.9% give all of its hydrogen to water to make a ton of hydronium. Okay, folks, that's the key, really. When you're talking about strength of acids and bases, it has to do with how much of the ion does it make in water. So since the hydronium ion is what's made by an acid in water, if you make a lot of hydronium in water, you're considered a strong acid, okay? By definition, acids make hydronium. So if you make lots of hydronium, you're considered a strong acid because you're making a lot of what acids make. So you're a strong acid because you're making lots and lots and lots of what you're supposed to make, okay? It says a strong acid is a strong electrolyte. It conducts electricity really well because remember, electrolytes have lots of moving charges. You have to have moving charges to have electricity. Well, if you're making lots and lots and lots and lots and lots of this positive hydronium, you're going to have a lot of charges. And so it's going to conduct electricity really well, all right? This example, sulfuric acid. Sulfuric acid is a strong acid because 99.9% of this will give its hydrogens away to water, making whole bunches of hydronium. And this species right here that's left after it's given up its hydrogen. Lots of charges. So it can conduct electricity really well. Okay. So strong acids make lots of H3O plus. If you can hold on to that and you can remember that, you got what a strong acid is. Okay, so then weak acids. I have a feeling that you could probably figure out what a weak acid's going to do or not going to do, but obviously I can't hear you. So let's see. You can be thinking to yourself and see if you got it. All right, a weak acid is going to ionize. It's still going to make hydronium. It's still going to give away hydrogen to water to make H3O plus, but it only does it partially. And when we're talking partially, we're talking like 0.01%, a tiny fraction of the little acid molecules are going to actually give their hydrogens away. Now, when you think about, like if I have a beaker of a weak acid, there's billions of little acid molecules in there. So 0.01% of billions is still a lot. But compared to a strong acid, it's not going to do this much. So a weak acid is going to make a tiny little bit, just a little bit of hydronium. It's still an acid because it's still making hydronium, but it's making just a tiny, tiny, tiny little bit of it. And that's why it's considered weak. It's acidic. It's making hydronium. It's just not making much. And it's going to be a weak electrolyte because there's not going to be a whole lot of charges. It's still going to be able to conduct electricity, but just not anywhere near as well. If you were trying to light up a light bulb with a weak acid, it would like just barely glow. If you light up a light bulb with a strong acid, it glows a lot. Okay. And then the example here is HCN. That's called hydrocyanic acid. It does still give its hydrogen to water to make H3O plus and cyanide, one of those polyatomic ions on our chart. We do still have some charges. So it can still conduct electricity, just not much. So weak acids make very little hydronium. Now, I forgot to point this out on the previous slide, so I'm going to go back for just a second. But before I do that, take a look at this arrow right here. Notice that we have a double-sided arrow. It's pointing both to the right and to the left. You may or may not remember back from chapter 8 a ways ago, but that means this reaction is reversible, okay? Folks, just visually, if you see a reaction and it has a double-sided arrow, that's a dead giveaway that it's a weak acid. Okay, that's a dead giveaway. You see that double-sided arrow, a double-sided arrow of any kind, you know it's a weak acid. All right. Back on the other one that I forgot to point out, here on the strong acid, notice this arrow is not double-sided. This arrow is only pointing to the right, only pointing to the products. You see a single-sided arrow just going to the products. I'm trying to get my cursor here. You see this just a straightforward arrow. That's a giveaway that you're talking about something that's strong. Okay, so an arrow that just goes one way to the right, that's strong. But an arrow that goes both ways, that's going to be weak. That's a visual giveaway. Now, this right here, this is from your textbook. You do have a textbook, by the way. I hope you know where it is. I hope you can locate it, put your fingers on it, or at least see it or know where it is, because those are going to have to come back to school at some point. You know, of course, none of us knows when the school building is going to be open again for people to do things like that. But regardless, those books have to come back because I got to keep using them. So hopefully you can still locate it. But on page 460 in your book, there is a table that has a list of strong and weak acids so that you can see. I think there's 7. There's only 7. It's 7? There's only 6 or 7. I can't remember. I should know this, but I can't remember off the top of my head. But there's only 6 or 7 strong acids. Everything else is weak. And they have a list of that in your book. All right, then for bases, it's going to work pretty much just like the acids, except where acids make hydronium, bases make hydroxide. So the terms is going to be the same type of thing. It's just for hydroxide here. All right, so for a strong base, as we mentioned before, when a base is dissolved in water, it produces hydroxide. This is called dissociation. Again, don't get hung up on those words. You just need to know what they make. A strong base, just like a strong acid, is going to dissociate completely, almost 100%, 99.99% in solution. So a strong base makes a ton of hydroxide, makes bunches and bunches and bunches and bunches of hydroxide ions, okay? And will also be a strong electrolyte because there'll be lots of charges. An example here is calcium hydroxide, okay? When calcium hydroxide is dissolved in water, it splits into the calcium ion and 2. I hope you remember from 2 weeks ago that 2, come on cursor, there we go, that 2 is there to balance the equation. These, even though these look weird, they still have to be balanced. 2 hydroxides on the right for 2 hydroxides on the left. But this is a strong base because it makes tons and tons and tons and tons and tons of hydroxide ions when it dissolves in water. And again, here's our visual clue. There's that one direction arrow pointing to the right that says, hey, this is a strong base. And then to finish it off, a weak base. I think you can figure it out. A weak base is weak because it dissociates just partially, 0.01%. Making hydroxide in solution. It's still going to make hydroxide, which is what bases do, but it does it such a small amount that it's considered weak. And it would be a weak electrolyte, just barely conducting electricity because of it. An example here is ammonia. Remember, ammonia was that kind of weird example that we had, I think, in our last notes 2 weeks ago. Ammonia doesn't have hydroxide in its formula, but it doesn't matter. Because in water, ammonia can take a hydrogen from water, and that leaves behind hydroxide. So even though it doesn't have hydroxide, it can make hydroxide with water. And it does make some hydroxide, but it makes very little hydroxide. So that's why it's considered weak. And again, notice our little visual clue here. We've got that double-sided arrow pointing both to the right and to the left. That lets you know just by looking at it that it's a weak base, okay? And once again, this is a page in your textbook that has a list of some strong bases and some weak bases, okay? All right, so now you have a very short little assignment on Classroom that goes with these notes particularly. I believe there's 10 questions that you're just gonna go in and type your answers to. Please, I'm begging you, please don't answer incomplete sentences. You're going to be typing these in. Like 1 to 2 words knocks these out, okay? You are more than welcome to reference this video again. That's what it's here for. It should be really short. It should be really simple. Make sure that you submit that for me when you are finished. And I am wanting to have a Google Hangout with you all tomorrow. I'm going to try to get a feel. I'll send a message through Remind, maybe kind of midday. I'll have one scheduled for about midday today, maybe around noon or somewhere around in there. Just kind of trying to get a feel for who can do the hangout tomorrow. I would like to give you all a lab experience with acids and bases, show you all the colorful stuff that can be done with them. I have a magic trick that I can do with it as long as all my chemicals are feeling magical while I'm at home. I've never tried it at home, but we'll see. But I'm going to try to get a feel from you all who is going to be willing to come to the Google Hangout. This will give you an opportunity to get, a very good lab grade. I would say at least 100. If you show up for, it'll be a good lab grade, folks. The grades that I give you, they can't hurt you. Okay, any grade that I give you from this point out has to be something that helps you. Okay, so it'll be a grade that will help you. It'll be a high lab grade with the possibility of some extra points on some things as well. So I would like to give that opportunity to you tomorrow. It'll be fun. It'll be nice to kind of see everybody, just to see, hey, we're still here. Hey, there you are, that kind of thing. But just to kind of give you a heads up that I'm going to be sending that remind out. I'll probably post it. I may post it to Google Classroom as well, but I am going to need to hear back from y'all to find out if you're going to be able to come to the hangout. If you can't come to the hangout, I'll probably record it and post it anyway. But so you can still do the lab experience. But I'd love to see you. I'd love to see you in person for that. So just wanted to give you a heads up on that. And like I said, again, if you'll just go on over to Classroom and go ahead and be finding